I want to introduce to you a term that is very, very loosely defined here. I want to talk about provenance. By provenance, what I mean is, where does the data come from and how did it come to be what it looks like? And it's a critical thing to think about whenever we're talking about reports. There are many things that we need to keep in mind when we want to write good reports, and one of those is somebody's going to look at the report and they're going to say, can you explain to me why this line item looks the way it does? And if you don't have the data provenance for where that data actually came from, you'll never be able to trace it back and provide them with that spot checking. Let's take a quick look. Let's say we have some financials data. And in this financials data, we have a bunch of different corporate entities for a bunch of different quarters and the revenue and the costs associated with these entities. And when you look at these entities, you might say, well, it looks like there's 5 entities here, but actually those first 2 companies are probably the same. This was maybe a data cleaning issue. And those last 2 companies, well, are they the same or not? It's a little bit hard for me to say, right? Under certain circumstances, if we were trying to assess how the company as a whole did, whether we're looking at the domestic branch or some branch that's incorporated outside of our location, maybe that doesn't really matter. We just sum those up. Under other circumstances, it may actually make a difference, whether we're looking at the overseas incorporated version or the local version. But whatever the case may be, we look at this data and we might say, okay, at the minimum, somebody's going to ask me for some data cleaning. They want to normalize this. Well, whenever we do this normalization, one of the things that we should think about is how do we make sure that that normalization is reversible? Or that normalization, especially if it uses a heuristic, that normalization is something that somebody can spot check later. I'll show you what it means from the perspective of provenance. If we took a look at this data, and we wanted to say, let's do some very simple cleanup of this data. So one of the things we might do is we might do a very simple heuristic. We'll split each entity into 2 words, and we'll just take the first word. And we'll split on spaces and maybe commas. So maybe we'll do something like this. We'll pull out that entity column like that. And here we'll grab the entity column by itself. We'll do a split on it. And we'll grab just the first entry here, and then we'll do another split on this. And we'll grab the first entry here, and there we go. We've normalized this. And now that we've done this, maybe we can actually set this thing back in. So what we'll do is we'll do an assign like that. And here we should have, and we can of course add that index back in if we wanted. It's a little bit more convenient than doing this on the index get level values directly. But here you can see we've done this normalization. But because we've done this normalization via some heuristic, there may be a situation where we've gotten it wrong. And we tried to find the easiest, the simplest way to clean up this data, but we accidentally cleaned something up that we shouldn't have. Maybe it's the case that 2 of these entities, Acme and Acme Corp, are legitimately distinct entities and our heuristic is actually wrong. How would we know that when we give this report to somebody? We wouldn't. And it would be very easy for this to slip under the radar for nobody to notice until they run into trouble and they say, well, hold on a second, we actually expect there to be 2 Acmes here because they're actually distinct entities. And then you have to figure out, I've been reporting these as aggregated together for a very long time. Well, one of the ideas that you might employ is you might try to prevent losing track of the original data. So rather than even doing something like a mapping here, where you're very explicit about how you map these, that's maybe a little bit better. You can kind of see that you're mapping 2 things to one. What you might instead choose to do is you might instead choose to make the entity mapping a little bit more visible. So here, if somebody asks, well, how did you get to this entity? They can actually see what the entity mapping is, and they can identify, independent of its application to the data, oh, hold on a second, these 2 shouldn't be joined together. Or what you could do, rather than that, and of course, if you do something like this, you can always kind of map through on your result. So here, your result would just be mapping through the entity mapping in order to do the aggregation. Or what you could do is you could add another column with the inferred entity. What you could do is you could preserve the original value and show what the original value is and what the inferred or the extracted value is. Let me show you on a slightly different example. Let's say for this data, we have some costs on this data, but we know that as a consequence of some agreement, the costs are capped. The costs are capped at a certain value, $1.25 million, and if the costs ever exceed that, we actually don't care about it for our report. One thing we could do for that data cleaning is say, oh, you know what? We actually just update this column, clean this column directly, do a clip on it, and here you can see the costs go from being out of bounds to being clipped within bounds. But just like in the previous example where somebody's going to potentially lose track of why did this data come out to be such a round number, maybe a better idea is to preserve the provenance of this data, just add another column and say these are the costs and these are the inferred costs, the parse costs, the costs according to such and such heuristic. In this case, the actual costs, because in our scenario, we're saying that they're capped at a certain value, so somebody else is picking up the tab, your insurance, some government entity is picking up the tab once you exceed this value. And what this allows you to do is it allows you to preserve the original data, be very clear about why it is that this field looks the way it does, because anytime somebody comes to you and they say, I'm not sure about this report, it's not unlikely that they've seen the raw data itself and they can't figure out between the raw data and what you reported to them, what happened in the middle. The idea of provenance is tracking what happened in the middle, and one of the ways that we do this in Pandas is by not mutating columns, by just tacking columns off on the end, and then when nobody cares about looking at them, we project them out. We only show the actual cost column, but up until the very last minute, we keep that column there, so it's visible, so we can see how this transformation looked. In a pure Python scenario, not in a Pandas scenario, we can see the same idea might be even more involved of a process. Let's say we have some raw data here. There was some normalization on these entities and values. And we do some parsing of this data in order to case fold these, in order to take maybe the first character, and then in order to categorize them. What we might do is we might want to track every step along the way, what the raw entity looked like and what line number it was on in the original report, what the parsed entity looked like, the name and the value that we extracted, and what the normalized entity looks like. And each step along the way, we might want to, because Python's garbage collector makes it effectively very easy for us to allocate new objects and for these objects to be deallocated when they're no longer in use, for us to track these together. And so what we might end up doing in the pure Python cases, we might have this normalized entity constructible via a class method from the parsed entity, the parsed entity constructible via a class method from the raw entity, and the raw entity, well, you just need the line number of the line. And when you actually parse this data, you take the raw entity and you construct a parse entity and you construct a normalized entity from this, so that when somebody says, I am really unsure why it is that this line looks the way it is, at some point, close to, but not quite at the very end of your report, just a microsecond, a line above the final line that prints out the data for the report, you can say, you know what, let's actually see where these came from. Let's say print out each entity's parsed raw, and we can see and let's take a look at what the actual entity looks like that we're going to operate on, and we can say, oh, you know, this line happened to come from this line number and this original source data. When we're dealing with large document data and we're not too concerned about how much memory allocating, because you can obviously see we're allocating memory for every previous step along the process, the idea of not mutating something, not changing something in place, but annotating something, building on top of it, and especially using things like a name tuple to build these name tuples or reference name tuples or data classes or reference data classes or reference data classes allow us to preserve the provenance of where the data came from, which is a critical capability to be able to say, this line number on this report looks this way because it came from this original source data through this process, and I can look at each step along the way, and I can see exactly where some heuristic that I applied incorrectly normalized the entities, incorrectly applied some heuristic.